Okay, so this is a quick review on topic 21. So this replaces that Zoom meeting. We did have a Zoom meeting, but I forgot to record the meeting. But these are the problems we went over. But this is a short version of topic 21, which is what we covered this week, or what you learned this week. So this week you learned topic 21 and topic 22. But topic 21 is where you add and subtract radicals. Now remember, when adding and subtracting radicals, you can only add or subtract like terms. So like terms would be terms that have the same index, so they all have square roots, okay, index 2, index 2, index 2, and they have the same radicands, and the radicands are the same. They're all 2y's. So those three terms, this term, this term, and this term, are all like terms. So I can write it as 1. And so you can look at 3 square root of 2y plus 4 square root of 2y is 7 square root of 2y. And then you're subtracting 9, so that's a negative 2 square root of 2y. All right, so that's number 1. Number 2, we have 4 square root of x minus 7 square root of y plus 2 square root of x. So when you look at those three terms, not all are like terms like this one was. Because notice this has a square root of x, and this has a square root of x, but this is not the same radicand. The indices are the same, but the issue is that this radicand's not. Now, so these are like terms. Those are like terms. So I have 4 square root of x and a 2 square root of x. Altogether, 4 plus 2 is 6. So I get 6 square root of x, and then this term left, minus 7 square root of y. And if I want to, I can put the square root of y term first. So it'll be minus 7 square root of y plus 6 square root of x. It does not matter which one I used. All right, number 3. When you look at number 3, we have 2 cube root of x plus 3 square root of x minus 5 cube root of x minus 6 square root of x. And so notice again, I have 4 terms, but they don't all have like terms. They're not all like terms. For one thing, this is cube root, so this index is 3, this index is 2, this is 3, this is 2. So they all have different indices. They all have the same radicands, but the problem is that the indices are different. But I do notice that this term and this term are like terms because they both have cube root of x. So this is 2 cube root of x and a negative 5 cube root of x. So 2 and a negative 5 is a negative 3 cube root of x. And then 3 square root of x and a negative 6 square root of x, those are like terms. I'm going to put 2 arrows there. Those are like terms. So 3 and a negative 6 is negative 3 square root of x. So there's your answer there. And if you want to put the square root of x first, you could. You would say negative 3 square root of x minus 3 cube root of x. All right, number 4, we have 6x minus 4 square root of x squared plus 3 square root of x. So in all the other problems we didn't, there was nothing to simplify. So we just combine like terms. Now we do though, you got to be able to simplify first. So when you see add or subtract, before you can add or subtract, you got to make sure that your terms are simplified as much as they can be simplified. So that way you can combine like terms. Here though, I can simplify the square root of x squared. From a previous lessons, we know that the square root of x squared is x, because x times x is x squared. So that's 6x minus 4x plus 3 square root of x. And that's all I can do in terms of simplifying. Now let's go about like terms. This has a square root of x in it. These do not. But I do know, if I cover this part up, I do know that I can combine 6x and a negative 4x. 6x minus 4x is 2x. So this becomes here, that becomes 2x plus 3 square root of x. And there's your answer there. And again, if you want to put the square root of x first, you can. So you can say 3 square root of x plus 2x. It does not matter. All right, so that's number 4. When you look at number 5, in number 5, we have we have 2 square root of 20x plus 3 square root of 45x. And so to do that, you got to remember some things you learned in the previous lessons. So let's just deal with the square root of 20x first. So I'm going to go off to the side. I'm going to simplify the square root of 20x. I can simplify the square root of 20x. I know by the product rule for square roots or radicals that I can write this as square root of 20 times the square root of x. And then let's think about a perfect square that goes into 20. Well, a perfect square that goes into 20 is 4. So it becomes the square root of 4, square root of 5 times the square root of x. And I can simplify the square root of 4 because that's 2. Now, we know that the product rule for radicals says that when you have two or more radicals that have the same index and you multiply them together, you can write as one radical. Just multiply the radicands together. So it'll be square root of 5x. So that part will go here. So it becomes 2 times 2 square root of 5x. Over here, we have the square root of 45x to do the same thing. So it'll be the square root of 45 times the square root of x. And then the square root of 45, a perfect square that goes into 45 is 9. So I can rewrite this as square root of 9 times the square root of 5 times the square root of x. Square root of 9 I can simplify. That's just 3. 3 times 3 is 9. Again, just like this, I'm going to rewrite this as 1 square root. So it'll be square root of 5x. So that is this, and that's this right here. So that becomes 3 times this. So that's 3 times 3 square root of 5x. Now simplifying this further, you keep on simplifying as much as you can. 2 times 2 is 4, so it becomes 4 square root of 5x. 3 times 3 is 9, so it becomes 9 plus 9 square root of 5x. And I want you to notice that both of these are like terms because they both have square root of 5x's. So remember, like terms, you have to have the same index, and they do. Index of 2, and the radicands are exactly the same, 5x, 5x. So 4 square root of 5x plus 9 square root of 5x. 4 plus 9 is 13. So that's 13 square root of 5x. So that's your answer there. Number 6. In number 6, we have, let me quickly find number 6. So number 6, we have the square root of 5x to the 7th minus 3x square root of 20x to the 5th. All right, so that's what I have there. And so, so just like we did in the previous problem, we're going to go ahead and simplify each of these. So let's talk about this first. Let's go off to the side and kind of simplify this. So the square root of 5x to the 7th. So just like we did this one, I know I can rewrite this using the product rule as the square root of 5 times the square root of x to the 7th. I cannot simplify the square root of 5 because the only perfect square that goes into 5 is 1. But I can simplify the square root of x to the 7th because we know that I can simplify this because the exponent 7 is greater than or equal to the index. But 7 is not divisible by 2. So the way we approach this was we think about, well, what's the largest whole number less than 7 that's divisible by 2? And the answer is 6. So I'm going to rewrite this as, so rewrite the square root of 5. So I'm going to rewrite x to the 7th as the square root of x to the 6th times the square root of x. Because x times x to the 6 times x is x to the 7. When you multiply like bases, you add exponents. 6 plus 1 is 7. So now I have this. I have the square root of 5. I can now simplify this. The square root of x to the 6th is x to the 3rd. 6 divided by 2 is 3. X to the 3rd times x to the 3rd is x to the 6th. I cannot simplify this any further because 1, the exponent is 1, 1's less than 2. Okay, now, but I can rewrite this product as 1 square root now. So I have x cubed times the square root of 5x. So that is this, and that's going to go here. So this becomes x cubed square root of 5x. All right, now let's talk about this right here, the square root of 20x to the 5th. I'm going to go ahead and write it right here. Square root of 20x to the 5th. Okay, so when we talk about simplifying the square root of 20x to the 5th like we did this, I'm going to write it as a product, so the square root of 20 times the square root of x to the 5th. So let's talk about a perfect square that goes into 20. A perfect square that goes into 20 is 4, so it'll be the square root of 4 times the square root of 5. And let's think about the square root of x to the 5th just like we thought about the square root of x to the 7th. So I can simplify this because 5 is greater than or equal to 2. But 5 is not divisible by 2. So let's think about, I want this to be an even number. So let's think about the largest whole number less than 5 that's divisible by 2. So that'll be 4 So it'll be x to the fourth, the square root of x to the fourth times the square root of x. 4 plus 1 is 5. So let's simplify. So now I have these four factors. So let's simplify each one if we can. I can simplify the square root of 4. That's 2. I cannot simplify the square root of 5. The only perfect square that goes into 5 is 1. I can simplify this now because 4 is divisible by 2. So it'll be x squared. The square root of x to the fourth is x squared because x squared times x squared is x to the fourth. And then I cannot simplify the square root of x because remember, you know you cannot simplify a radical that contains a variable if the exponent is less than the index. But I know I can multiply these together because the indices are the same. So this becomes 2x squared times the square root of 5x. And so that's your answer there. Oops, sorry. That is this. So that's just this part here. So I get minus 3x times this. So that times 2x squared square root of 5x. Okay, so a lot of work to get to this point. All right, so let's simplify this as much as possible. So I'm going to rewrite this over because there's nothing else I can do with that one. But I can do something with this because we know that 3 times 2 is 6. And we know that x times x squared is x to the third times the square root of 5x. Now I want you to notice that those are like terms now. You have x cubed times the square root of 5x, x cubed square root of 5x. But I have 1 here, so that's a 1, and I have a negative 6 here. So 1 and a negative 6 is a negative 5. So this becomes negative 5 x cubed square root of 5x. So that's your answer there. So that's the answer for number 6. Okay, but notice all the stuff you had to do to get to that point. All right, so number 7. So let's look at number 7. All right, in number 7, you had 3 times the cube root of 16x to the third plus 4x times the cube root of 54. So 3 cube root of 16x to the third plus 4x cube root of 54. All right, so just like we did a while ago, let's go off to the side and kind of simplify these cube roots. So let's go off here and do the first one. So that's the cube root of 16x to the third power. So by the product rule, I know I can rewrite this as the cube root of 16 times the cube root of x to the third. Now remember, we're dealing with cube roots, so think about what's the largest cube root that is a factor of 16. And so that's going to be 8. Remember, 8 is a perfect cube. So that's going to be the cube root of 8 times the cube root of 2. 8 times 2 is 16. 8 is a perfect cube. And then over here, that's a nice one because 3 is divisible by 3. So the cube root of x cubed is just x, because x times x times x is x cubed. Now I can go and simplify this further though, because I know the cube root of 8 is 2. I cannot simplify the cube root of 2, and I get x there. So notice I have 3 factors. So I'm going to put the 2 times x in front of the radical. So I tend to put the radical on the end. So it becomes 2x cube root of 2. All right, and I tend to do that so that way the x doesn't look like it's inside the radical. So this right here is just this, right? And that's just this right here. So don't forget about that 3 right here. So it'll be 3 times 2x cube root of 2. Now let's go and talk about the cube root of 54. So the cube root of 54, so we got to think about a perfect cube that goes into 54 evenly, and that's going to be 27. So I get the cube root of 27 times the cube root of 2. 27 times 2 is 54. We know the cube root of 27 is 3, because 3 times 3 times 3 is 27. Let's put the cube root here, times the cube root of 2. Okay? So that is just this. So this becomes plus 4x times 3 cube root of 2. All right, now simplifying each one of these now. 3 times 2 is 6. So I get 6x times the cube root of 2 plus 4x times 3 is 12x plus 12x cube root of 2. Now I want you to notice, see you have x cube root of 2 and x cube root of 2. So those are now like terms because you have an x cube root of 2 and you also have an x cube root of 2. You have 6 here and 12 here. So altogether there's 18. So that's 18 x cube root of 2. So that's the answer there. All right. So in terms of topic 21, that was a quick review of some of the ideas that you learned this week, and I think also at the end of last week in terms of topic 21. Okay?